Suppose a plus b plus c equals to pi radians. Then we need to show that cosine of 2a minus cosine of 2b minus cosine of 2c equals to -1 added to 4 times cosine of angle A, sine of angle B times sine of angle C. Okay, let us begin. We'll start our proof from the left hand side. Now before beginning, let's try to understand why this is a conditional trig identity problem. That's because if we consider our standard trig identity given by sine squared theta plus cosine squared theta equals to 1, so this identity is going to be true for any values of theta that we choose. However, our problem is only going to be valid for this particular value of a, b and c. That means we need to choose the value of a, b and c in such a manner such that their sum always equals pi radian, and only then we can say that the given identity is going to hold. So that's why it's a conditional identity. So what we'll do, we're going to consider the left hand side of the equation. We have cosine of angle 2a minus cosine of angle 2b minus cosine of angle 2c. So what we'll do, we're going to combine the second term and the third term by taking negative as the common factor, such that we get cosine of 2b plus cosine of 2c. The reason why we're going to combine is because we have a standard formula. So let's note down that formula. Since cosine of angle alpha plus cosine of angle beta, so this is given by 2 times cosine of the angle alpha plus beta over 2 multiplied to cosine of alpha minus beta over 2. So here we will suppose that alpha corresponds to 2b and beta corresponds to 2c, such that we get cosine of angle 2a minus 2 times cosine of angle. Now we need alpha plus beta over 2. Now what is alpha? That's 2b, and beta is 2c. So 2b added to 2c divided by 2 simply gives us b plus c, multiplied to cosine of alpha minus beta over 2. That's going to give us b minus c. Fine. Now cosine of 2a. So what we'll do, we're going to expand cosine of 2a, because here, as we can see on the right hand side, we have a term which is -1, and we know that cosine of 2a, it has several forms. One of the form is given by 2 times cosine squared a minus 1. So if we use this particular form, then this -1 is going to take care of the term that we need on the right hand side. So cosine of 2a can be replaced with 2 times cosine squared a minus 1. Now coming to, we have -2 times cosine of b plus c, but we're going to work with b plus c as well. Since we know that a plus b plus c, that's equals to pi radians, so let's keep the second term and the third term on the left hand side and transpose the first term, which is a, to the right hand side to get pi minus a. Now we're going to take the cosine on both sides, such that we have cosine of b plus c, that's going to be equals to cosine of pi minus a. Now what is cosine of pi minus a? That's simply negative cosine of a, and we're getting a negative sign here because pi minus a means we are in the second quadrant where the cosine function is negative. So in other words, what we have done here is we have shown that cosine of b plus a, this is the same as negative cosine of a. So here, in place of this cosine of b plus c, we're going to replace it with negative cosine of angle a. Now we already have a negative sign here, so this is going to become positive. So we get 2 times cosine of angle a multiplied to cosine of the angle b minus c. Now let's rearrange the terms. We're going to take -1 as the first term. Next, we are left with, so there are in total 3 terms here. Now from the first term and the second term, what we will do, we're going to take +2 times cosine of angle a as the common factor, such that we now have cosine of angle a added to cosine of angle b minus c. Now the next task will be to combine these two cosine functions, but before that we will need to change this cosine of angle a to an angle which comprises of angle b and angle c. So again, we're going to use this fact that a plus b plus c equals to pi radian, but this time what we'll do, we're going to keep a on the left hand side and transpose b and c to the right hand side to get pi minus b plus c. Now let's take cosine of that angle on both sides. So cosine of angle a, that's going to be equals to cosine of the angle pi minus b plus c. Now what is cosine of pi minus b plus c? That's going to be negative cosine of the angle b plus c. Again, we are taking care of the fact that pi minus some angle b plus c means we are in the second quadrant where cosine function is negative. Meaning, in other words, we can replace cosine of A with negative cosine of B plus C. Let's do that. We have negative 1 added to 2 times cosine of angle A multiplied to, so cosine of A is a negative cosine of B plus C. So what we'll do, we're going to write this term first to get cosine of angle B minus C. And in place of cosine of A, positive cosine of A, we can replace it with negative cosine of B plus C. Fine. So now what we have is difference of two cosine function. There is also another standard formula to combine the difference of two combined function. So let's use that. So let's write it down first. So we have cosine of alpha minus cosine of beta. So this is going to be equals to 2 times sine of the angle beta plus alpha over 2 multiplied to sine of the angle beta minus alpha over 2. So here what we'll do, we will suppose that B minus C, that corresponds to alpha, and B plus C corresponds to beta. Okay, so now we have negative 1 added to 2 times cosine of the angle A multiplied to, so cosine of B minus C minus cosine of B plus C, that's going to give us 2 times sine of the angle. So now we need beta plus alpha. So beta plus alpha means B plus C added to B minus C. So that's going to give us 2B divided by 2 multiplied to sine of the angle. We need beta minus alpha. So B plus C, and from here we subtract B minus C. So that's going to give us 2 times C over 2. Okay, so further simplification is now going to give us negative 1 added to 2 times cosine of the angle A multiplied to sine of the angle B multiplied to sine of the angle C, and this is exactly the expression on the right hand side. So let's verify that. So we have negative 1 added to 4 times cosine of A, sine of B, sine of C. The 4 is coming actually because I forgot to multiply this 2 with 2. So this is actually 4. This is not 2, but this is 4. So we have successfully showed that the left hand side equals the right hand side. Hence proved.